multiply the following rational expressions. So x to the 2n plus 2 times x to the n over x to the n plus 1 plus 2x. And the second one is x squared minus 3x over x to the n plus 1 minus 3x to the n. Now this looks a little bit cumbersome at first, but once we factor things out, it'll look a little bit nicer. So let's rewrite each of these terms. So x to the 2n you can think of as x to the n squared, right? But another way to think of that is x to the n times x to the n, right? Because when we combine these, we add the exponents, which gives us n plus n, which is 2n. So let's write it that way, and then we'll keep 2x to the n as is. And then x to the n plus 1 is the same thing as x to the n times x to the first power, right? Because remember, when we combine them together, we get we add the exponents. So we get x to the n times x to the 1 is equal to x to the n plus 1. So I haven't changed anything so far. And then we'll write that 2x there. Then for the second term, x squared minus 3x, we can factor out an x. We can see right away, but I'm just going to rewrite it right now, and we'll factor out later. So x squared is x times x minus 3x. And then finally, for the last term, x to the n plus 1, just like in the denominator of the first, we can write as x to the n times x, or x to the first power. And then we get 3 times x to the n. So now that we've sort of factored things out in a more easier way, we can try to see what terms each of these numerators and denominators have in common so that we can factor them out. So notice in the first, there's an x to the n in common. So if we factor out an x to the n, we're left with an x to the n here plus 2. In the denominator, looks like we just have an x in common. So let's factor out an x, and what we're left with is x to the n plus 2 times, factoring out an x, we get x minus 3, since there was an x in common, and here there's actually an x to the n in common. So if we factor that out, what we're left with is x minus 3. So now we can combine these two rational expressions, and combining rational expressions is, we use the same method as we do for combining fractions. Basically, a over b times c over d is equal to a times c over b times d. So the product of the numerators over the product of the denominators. So let's just combine everything. I'm not even going to rewrite it. I'm just gonna straight combine. So x to the n times x to the n plus 2 times x minus 3. X to the n plus 2 times x to the n times x minus 3. And so now these are all related by products. We're multiplying everything in the numerator together and everything in the denominator together, so we can start canceling things out. So there's an x to the n plus 2 on the top and on the bottom, and an x minus 3 on the top and on the bottom that we can cancel out. So rewriting our expression, we're left with x to the n times x on the top, and x times x to the n on the bottom. Oh, but look! There's an x to the n on the top and the bottom, and an x at the top and the bottom. So these all cancel out. And remember, when something cancels out in a quotient, what you're left with is 1, not 0. So in the numerator, you're going to get 1. In the denominator, you're going to get 1. And this reduces simply to just 1. So 1 is the final result.